When a recursive function is called, there's two ways that information can be passed from one iteration of the function to the next. One is the first function call passes its parameter to the next function call. And actually what happens in between is the state of the program. All of the other program variables and everything are saved at that point. The function calls the next iteration of the function and passes a parameter. So it has this version of the function has a different parameter value from the previous version of the function, and that continues on down the line until it gets down to the point at which there is an ending condition triggered in the function. Once the ending condition is triggered, that particular iteration of the function returns a value or returns its state back to the previous function. So if it returns a value, that is another way that this function or this iteration of the function can return information to the previous function call. So there's two ways. One is to get from information can be passed down the ladder. It can also be passed back up the ladder in the return statements. And at this point, whatever was going on when this function was called, the state is restored other than the return value. So there's two things going on here. One is parameters are being passed down, return values are passed back up. But the other thing that happens is the state of everything else in the program during this function call is saved. And then it's different for this function call, and that state is saved. It's different for this function call, and that state is saved, and it continues on down the line. And then when the ending condition is triggered and it starts going back up, the state of everything else in the program is returned to where it was before. This is why a recursive function can only be called a certain number of times before the program or the system will end it, because it does actually save a lot of extra information, and it eventually will fill up available memory if it goes on too long. And that is also why the state of your program when the function is first called here can be different when this function is called here, and sometimes that confuses students that things are not what they expect them to be. So the only thing that you should be passing is through the parameters as you go down the chain, and through return values as you go back up the chain. So here's an example. We have a very simple recursive function here, and this statement here is calling it. I'm just going to print out the result of it, and the function is called multiply. It multiplies the two parameters together. So in this case, I'm giving it 3 and 4. So the parameter A gets the value of 3, the parameter B gets the value of 4. And as it jumps into the multiply function for the first iteration, A is 3, B is 4, and it does this. If B is 0 or A is 0, that is not true, so it's going to skip that. Then it's going to test to see if B is 1. That is not true, so it's going to skip that. It's going to go to the else clause, and it is going to return A, which is 3, plus it's going to call itself using A and B minus 1. So we see that here, 3 plus the multiply of 3 and 3 is the value that gets returned. But in order to return this value, it first has to call multiply. So it goes back into multiply with the values of 3 and 3. So this, for the second iteration of going into multiply, A is 3, B is 3. Again, it does the tests, ends up coming down here because A is 3, B is 3. So it returns 3 plus the result of multiplying A and B minus 1. So it goes 3 plus the result of multiplying 3 and 2. Okay, so then it goes, well, I still need to figure out what this is, so it goes back in for a third iteration with the values of 3 and 2. So now A is 3, B is 2. This is false, this is false. It's going to go to the else clause again. It's going to return A plus the result of calling multiply with A and B minus 1. So I've got A is 3, B is 2, and I'm going to return 3 because A is 3, plus the result of multiply 3, and now B minus 1 is going to be 1. So I'm going to call multiply again in order, before I can return this value, I need to figure out what this multiply is. So I'm going to call multiply one more time. And I'm going to have A is 3, B is 1. That's the values for my fourth iteration here. Neither one of them are 0, so I'm going to skip that. But B is 1. That is true. So this time I'm just going to return A. So this iteration returns a value, a simple value of 3. So 3 gets plugged back into this iteration right here. The result of this multiply call is 3. So 3 plus 3, that gets resolved, and now this iteration can return, and it returns back to the previous iteration with a value of 6. So this call to multiply resulted in 6. So I've got 3 plus 6, which results in 9. So this is now resolved, and it can return its value to the previous call. Okay, so I've got 9 going in here. So this becomes 9, and I've got 3 plus 9, and that was the first iteration. So it is returning all the way back to this call of the original call of the multiply. So you can see it's starting here, it's calling down this way, and it doesn't, until the ending condition is triggered, it can't figure out, it can't resolve the value to return. That's what's happening here, is every time it tries to return a value, there's something more that it has to resolve before it can continue to actually return the value. So it has to do another function call. And that's the way this works. It tries to return its value, but it can't. It has to resolve the value, so it calls again, and it calls again, and it calls again, until it gets to the ending condition. Once it gets to the ending condition, it starts to actually return values that are resolvable. So it returns back, returns back, returns back, and that is what's happening here. The first function call cannot resolve this, calls again, and it still can't resolve this, so it calls again, still can't resolve this, calls again, finally hits the ending condition, is able to resolve to a simple value, and now it can plug that in and go all the way back up the line. One more thing that I have seen students running into, and it is mentioned, I believe, in the book, but doesn't go into a lot of detail, and that is recursion can occur not only when one function calls itself, but indirect, this is one function calling itself, that's what we've been doing. But indirect recursion can also occur when one function calls another function, and that function either calls back to the original function or maybe even calls a third function, but they're kind of calling each other in a loop. And I've seen students doing this with a menu type of program where rather than using a loop, they're calling the menu. And the problem that students run into that they don't anticipate is every time you call a function, it waits in it, until that function is able to resolve and complete. It saves the previous state, and the state at which you enter the function can be different than what it was because it's hasn't yet returned from the previous call. So hopefully that will help you out a little bit.